Hello and welcome. This is Bijan FHR.
Our objective is to create first hop redundancy using hot standby router protocol HSRP for this network. We are going to create a virtual gateway for PC1, PC2, and PC4. This internet network has three routers in it. Router 1 and Router 2 are Cisco 2811 routers. Router 3 is Cisco 2911 router. The three switches, switch 3, switch 2, and switch 1, are 2960 Cisco switches. All devices are connected to each other using a straight route, except PC3 to gigabit interface of router 3 and switch 1 to switch 2, which are using crossover. First, we need to do the basic configuration on routers. We start from router 1. We go to command line interface, enable conft host name R1, interface FA00, IP address 192.168.1.1.255.255.255.0, no shot. Exit. Interface FA01, IP address 192.168.2.255.255.255.0, no shot. The basic configuration on router 1 is completed. We have renamed it. We have configured FA00 with this IPv4 address and subnet mask, and FA01 with this IPv4 address and subnet mask. We go to router 2. Enable conft host name R2, interface FA00, IP address 192.168.1.255.255.255.0, no shots. Exit. Interface FA01, IP address 192.168.2.255.255.255.0, no shot. Basic configuration on router 2 is completed. We have renamed it, and we have configured FA00 with this IPv4 address and subnet mask, FA01 with that IPv4 address and subnet mask. We need to perform the same basic configuration on router 3. Enable conft host name R3, interface G00, IP address 192.168.2.3, 255.255.255.0, no shot. Exit. Interface G01, IP address 192.168.3.3, 255.255.255.0, 0, no shot. The basic configuration on router 3 is completed. We have renamed it to R3. We have configured G00 of it with this IPv4 address and subnet mask, and G01 of it with that IPv4 address and subnet mask. There are 3 networks in here: one network, 2 network, the second network, and the third network. Therefore, we need to configure routing for this internetwork to work and have end-to-end connectivity. We can do a static default route and also dynamic routing protocol. For this activity, I'm going to be using EIGRP. So I'll go to router 1, exit to global configuration mode, router EIGRP, autonomous number 11, network 192.168.0.0 with the wildcard mask of 0.0.255.255, enter, no auto summary. It's done. I'm going to perform the same thing on the other routers as well. Router 2, exit to global configuration mode, router EIGRP 11, the same network and wildcard mask and no auto summary. I'm going to do the same thing on router 3. Exit to global configuration mode, router EIGRP, the same autonomous number, same network, no auto summary. Then exit to global configuration mode. I'll do the same thing on the other routers, exiting to global configuration mode. Now we have performed the basic configuration, plus we have configured EIGRP, autonomous number 11, which is a dynamic interior gateway routing protocol, Cisco proprietary, on all these 3 routers, so they can exchange information about their attached network with other routers. Router 1 is going to inform router 1 and router 2 of this network because they don't see it, they are not directly connected to them. And router 1 and router 2 would introduce this network to router 3. So if you go to router 3 and go to the privilege mode and perform show IP route, you'll notice that it has obtained a path to the remote network using EIGRP, which is network 192.168.1, this network. And if you go to router 1 and perform the same command, you'll notice that it has a path right now. It has a route to network 3, and we can perform the same thing on router 3, show IP route, do show IP route. Since we are not in the privilege mode, we cannot perform the show command unless we put a do in front of it. As you see that router 2 also has a route, and can forward packets to network 3, which is a remote network, to it. Now that we have configured all the 3 routers with basic configurations and also routing protocol, we use EIGRP, it's time to go ahead and configure first hop redundancy for this network using HSRP. In order to do that, we need to work with fast Ethernet 00 of router 1 and fast Ethernet 00 of router 2. First, we access router 1. We go to privilege mode, then global configuration mode. Then we access interface fast Ethernet 00. The command to start configuration is standby. Standby. We need to create a group for routers to be part of that group. That group must be identified with a number. We use number 1. Then after that, we can use different keywords. If we use keyword IP, we need to follow it with the IP address of virtual default gateway that we want to use. We want to use 192.168.1.254, which is not assigned to any interface of router 1 and router 2. It has not been assigned to any of the PCs in the internetwork that we see. And then we need to assign a priority to fast Ethernet 00. By default, the priority is 100. Priority is the first criteria for electing active and standby router. The higher the priority, that router with the higher priority will become the active router. So in order to do that, in order to change the priority, the command is standby for group 1, priority 105. I change the priority of FA00 of router 1 to 105. If we do not change the priorities and we keep them at default value, the highest IP address will dictate which one is going to become active, or the first one that is booted. In here, I want to force router 1 to be the active router. Therefore, I change the priority of it to a higher priority than the default value, which is the priority of the router 2. Another command is standby for group 1, preempt. Normally, you do this command only on the router with the highest priority that you want to force to be the active router. So the configuration on router 1 is completed. Let's go to router 2. The election has already taken place. This router is standby router, but let's perform other configuration on this one. Go to global configuration mode, interface FA00. We want to put it in the group 1, standby 1, and then we want to introduce the IP address of the virtual default gateway. We want to configure this one with that IP address as well. 68.1.254. I want to change the priority of it. Standby for group 1, priority 104. There is no need for me to preempt this one. This is going to be a standby router anyway, because I have assigned a lower priority to it. Now let's go ahead and examine the configuration to see if we can verify it. Do show standby on router 1. We are performing this command, show a standby in privilege mode, or if you are not in privilege mode, you type do show a standby on router 1. It says this router is part of group 1. The role of it is being active router. The virtual default gateway is configured to be 192.168.1.254, and the standby router has this IP address, which is router 2. Also says the priority of router 1 is 105. And we can go ahead and perform the same show command on router 2, and to go to privilege mode and then perform show standby, show a standby, show standby. Router 2 is part of group 1. The status of it is standby, backup router. It is configured to use 192.168.1.254 as the virtual default gateway, and the IP address of the active router, which is router 1, is 192.168.1.1, which is correct. The standby router is local, meaning router 2 is a standby, and the priority of it is 104. So the configuration is verified. Now we need to configure the end devices. As far as the PC3 is concerned, we are going to assign IP address of 192.168.3.254 to it with this default subnet mask and this default gateway IP address, which is the IP address of G01. For PC1, we are assigning the IPv4 address of 192.168.1.10 with that subnet mask, and we give the virtual gateway IP address as the default gateway of it. On PC2, we assign a unique IPv4 address, its subnet mask. We assign the same virtual gateway IP address as its default gateway. On PC4, a unique IPv4 address, subnet mask, and the same virtual gateway IP address as its default gateway. Let's test end-to-end connectivity from PC1. We are going to perform a ping command, ping 192.168.3.254, which is the IP address of PC3. Replies are coming back. The packet is being forwarded through fast Ethernet 01 of the router 1, because it is the active router. The router 2 is standby, it's just sitting there in case this link goes down, then it will perform the forwarding. Let's ping PC3 from PC2 also, ping 192.168.3.254. There is connectivity. Now let's test. Let's go ahead and shut down port FA024 of switch 1 to see if we can still ping end-to-end. Enable conf t interface FA024. When we are there, we go shut. We shut it down. If we shut it down, this link will go down. Let's see if we can still ping PC3 from PC1. Still replies are coming back because it is not the physical IP address of router 1 that is used as the default gateway. It is this virtual default gateway that is being used. Now packets are being routed through router 2. Let's examine the status of the standby. Show standby. Notice that router 2 changed role to active. It still remembers the virtual default gateway IP address. Its priority is still the same. So that's how you configure a first hop redundancy using HSRP to make sure that you have a failover system for the default gateway, because it's not possible to configure any one device with more than one default gateway address. If you don't have first hop redundancy, then if the default gateway link or interface or router fails, PCs are going to be confined to communication within their own network. They cannot exit from their own network.
Thank you for watching. If you liked the video and you found it informative, please don't forget to recommend it to others who may be interested. Thank you.